Entropy. Everyone's talking about it, but at this point, I don't know what it is and I'm too afraid to ask. Let's get into it. Entropy is the measurement of randomness, uncertainty, or surprise in a system. And it's especially important in cryptography because the more entropy a secret key has, the harder it is to guess. It's possible to create a private key that has so much entropy that it becomes computationally infeasible to guess. For example, let's take a Bitcoin private key that has 256 bits of entropy. Guessing that private key is like finding a very specific atom in the observable universe and still having several universes worth left over. As you can see, 256 bits of entropy is the gold standard, but what's a single bit of entropy? What does that look like? Well, you can think of it like a coin flip. It can either be heads or tails. Similarly, a single bit of entropy is binary. It's a 0 or a 1. 2 bits of entropy is like two coin flips. So you have four possible outcomes. You can either have heads, 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 tails, tails, heads, or tails, tails. And 2 bits of entropy in binary is either 0, 0, 0, 1, 1, 0, or 1, 1. It's easy to see how with each new bit of entropy that you add, the number of possibilities doubles in size. Now, it's worth noting that all of these possibilities have to be equally likely. It doesn't count if you have a biased coin that's, weighted on one side so that it has a higher chance of, let's say, landing on heads. So how do we get good entropy? Because it's possible to have a 256-bit key that doesn't have 256 bits of entropy. This can happen if some of the bits are known or if they are very likely to be a certain value. What's a good source of entropy? Well, we can start with humans. Humans are a very bad source of entropy. We are bad at making random numbers. Our brains are always trying to create patterns. You also can't really write an algorithm for random numbers because by definition, an algorithm is deterministic. It takes an input and the output is the same every single time. The best place to get entropy is our physical, natural world. For hardware, that's going to mean voltage fluctuations, which are these like tiny, unpredictable variations in voltage over an electric circuit due to just ambient noise. They can also come from thermal noise, which are these like little electron jitters that happen in resistors due to heat. Another way that Bitcoiners like to get entropy is by rolling dice over and over again, and then they include that in the generation of their secret key. Cloudflare is famous for having this big wall of over 100 lava lamps that they film and use the ever-changing motion of the blobs as a source of entropy. At the end of the day, though, every single lock we use in the digital world, whether that is a password, a PGP key, a Bitcoin seed phrase, it all rests on this quiet promise that it was chosen with enough randomness such that no one would ever be able to guess it. And this is something we don't think about that much. We often let software automatically generate these values for us, but that trust doesn't have to be blind. With open source software, we are able to audit the code that our devices are running on, and in the case of entropy, make sure there's a high enough level of it and that it comes from a place of true randomness. If you like this video, I'm Satsy. I work on the Bitcoin Dev project. You can find us at bitcoindevs.xyz or the handle Bitcoin_devs.